Okay, so I'm going to review some factoring techniques that you learned in Algebra 1 with a few examples here. If you recall, the first step of factoring should always be to factor out the greatest common factor. So I'm looking at this first example here, 6x squared minus 30, and I am noticing that the greatest common factor that they share is 6. So I pull out the greatest common factor, 6, and then I have to figure out what is left after I factor it out. So 6 times what gives me 6x squared, or 6x squared divided by 6 is x squared. I'm going to copy the minus sign, and then 6 times what gives me 30, that's 5. So the next step of factoring is factor if you can again. Well, I'm looking at x squared minus 5, and I'm noticing that does not factor any further. It's almost what we call difference of squares, but it's not because 5's not a perfect square. So 6 times the quantity x squared minus 5 is my completely factored answer. Taking a look at the next example. Once again, I'm going to check step 1, which is look for GCF. I notice there is not only a number this time, but also a variable in common. The greatest common factor is 3x. So I pull out the greatest common factor. I'm going to copy the minus sign. I'm focusing just on the first term and the greatest common factor, 3x. So 3x times what is 3x cubed, or 3x cubed divided by 3x is x squared. Now I'm moving on to the second term. So 3x times what is 12x, or 12x divided by 3x is 4. So I have 3x times the quantity x squared minus 4. Now I'm doing step 2, which is check to see if I can factor further. This time I do have what we call difference of squares, and hopefully you remember how to factor using difference of squares. So I'm first going to copy the 3x. Using the technique of difference of squares, I am going to write 2 sets of parentheses for my 2 binomial factors. I know to do this because I'm noticing that I have a perfect square, x squared, minus sign, a perfect square, 4. So that's when we use difference of squares, when we have minus and the 2 terms are perfect squares. So I'm going to figure out what do I square to get x squared? Well, that's x. So I put that as the first term in each of the binomials. I'm going to do the same thing with the 4. What do I square to get 4? That's 2. That goes as the second term in each of the binomials. Then with difference of squares, I have to write 1 as plus and 1 as minus, and the order there doesn't matter. I could have written minus 2 here and plus 2 there. But that's how we factor using difference of squares. Now, there's nothing else to factor, so I have the completely factored answer, 3x times the quantity x plus 2 times the quantity x minus 2. Let's try a couple more examples. So we're going to take a look at x squared plus x minus 6, and we're going to factor that. So I do not notice a greatest common factor. There is no greatest common factor between those 3 terms. So the step 1 is complete. Step 2, I'm noticing that this is a trinomial rather than a binomial. So I know that when there's a trinomial, I'm going to use what we call the diamond technique. And what that entails is looking at the leading coefficient, which is a 1, and the constant, which is a -6, and we're going to multiply them together. So 1 times -6. When I do that, I get -6, which becomes the top of the diamond. Next, the middle coefficient, which in this case is a 1, is the bottom number in the diamond. So now what I have to do is think about factors of the top that add to the bottom. So factors of -6 that add to 1. And for the moment, I'm going to just ignore the negative and think about factors of 6. So I know that my options are 6 and 1, or 3 and 2. Now, of those 2, I want the combination of the 2 numbers that are 1 away from each other, or together add to 1. I can see 6 and 1 is not going to do it for me. 3 and 2 are 1 away from each other. So 3 and 2 are my 2 numbers. Now I'm going to worry about the sign though, and it is a -6, which means to get a product of -6, one of these 2 numbers is going to have to be negative. I have to decide which one, and I'm going to look at the positive 1 and think which number needs to be negative so that when I add the 3 and the 2, I'm going to get a positive 1. So I know that means the 2 is what needs to be negative. 3 plus negative 2 is positive 1, and 3 times negative 2 is negative 6. So now I'm ready to write my factors, and I know that I can go right to the binomials because the leading coefficient was only a 1. When the leading coefficient of a trinomial is a 1, and we've already checked for greatest common factor, we can go right from these two numbers to our answer, to our binomials. So I know that to get x squared, I need x and x, because x times x is x squared. And I'm just going to take the positive 3 and the negative 2 from the diamond. And now I have these two factors which cannot factor any further. Therefore, that is my solution. Let's take a look at the next example. So we're going to start this one the same way. We're going to make a diamond. 6 times negative 2 is negative 12, and the middle term is negative 1, the coefficient. So I'm thinking factors of 12. So 6 and 2, 3 and 4, or 12 and 1. And I want those numbers to be 1 or negative 1 away from one another and or add up to 1. So I can see that 3 and 4 is what's going to do it for me. Now I'll worry about the sign. I know one of them needs to be negative, and I need the sum to be negative 1, which means the 4 is the number that needs to be negative. Now I cannot go right to the answer like I did in the last problem, because this time our leading coefficient is not a 1, it's something else, it's a 6. So my next step is to make what we call a generic rectangle. So we have 4 boxes here. And what we'll do is we'll take the first term and we'll put it in the first box. And you'll always do that. And you'll always take the last term and put it in the last box. We're going to take these two numbers from our diamond, 3 and negative 4, and we're going to put those with x's, and we're going to put those in the other two boxes. The order does not matter. These could have been reversed, and it would still work. Now what I'm going to do is I'm going to factor the greatest common factor. I'm looking across the rows. And then I'm going to look down the columns, each time pulling out the greatest common factor. So I'll start with 6x squared and 3x, and the greatest common factor I see is 3x. I'll do the same thing with the next row across, negative 4x and negative 2. The greatest common factor is negative 2. Going down the first column between negative 4x and 6x squared, I see that 2x is the greatest common factor. And going down the last column, the only factor that I see in common is a positive 1. So I should check this just to be sure that especially my signs are correct. I didn't make a mistake. So 3x times 2x is 6x squared. That's correct. 3x times 1 is 3x. Yes. Negative 2 times 2x is negative 4x. And negative 2 times 1 is negative 2. I have just confirmed that these are the factors of my original expression. So I'm going to go ahead and write them. 3x minus 2 from this, and 2x plus 1 from this. And I do not see anything that I can factor further, so that is my final product. I should also mention that at the beginning there was no greatest common factor, so I didn't even have to start with that as our first step. So this is my final solution for 6x squared minus x minus 2.